Hello everyone, welcome back to my channel. I hope you guys are doing well. This is the fourth video of this series, Ease into Coding along with Complexities. So if you have not yet checked out my previous videos from this series, you can check them out by clicking on the I icon above. Also, if you haven't subscribed my channel yet, don't forget to subscribe and also hit the bell icon to never miss an update. Coming back to this question, I've again taken up a question from LeetCode itself, and I'll be pasting the link in the description box below. If you must have gone through this question, as you can see, this question is of medium range, and to bring to your notice, this question was asked in several technical interviews. Also, one of them was the Amazon technical interview. So pay close attention to this question. If you must have gone through this question, you will be knowing that in this question we will be provided with the following input, in which we will be given with the input vector and with the following elements, and what we need to return is all the elements that are repeated basically, and we need to contain these all repeated elements in a vector, and that vector is to be returned. There are variety of approaches to solve this problem, but I would be basically solving this problem using three basic approaches. Let us get back to our whiteboard in order to understand this problem well. Let our first approach be something like that. If you must have checked my previous video, I had implemented the code using a set, and the same set we are going to use over in our first approach. So how will set be useful to solve this problem? Basically, in set, we know that a set is a container which has all its elements in sorted order, and also a set has a unique property that all its elements are going to be unique. If that is the case, what we can do is one by one we can start inserting our elements from the vector inside the set, and in case if we insert a repeated element, our insert function is going to return a false, and that can be useful in analyzing what exactly is the repeated element, and that could be pushed back to the vector, and that vector can be finally be returned from our function. This is the approach we'll be using in this problem, and let us see how I have implemented it. So first I have declared a set with the name s1, and also a vector of type int with the name v1, which is to be returned from this function. Now we are starting from 0 and going up till the size of the vector, and the thing I'm going to check over here is the dot second property of insert. Now if you must have again noticed in my previous video, I had explained over there what our insert is going to return. Insert is basically going to return a pair. The first element of that pair is going to be an iterator pointing to the element that was inserted, and the second element is a bool value basically, which will return true if the element was successfully inserted, or false if the element was not able to be inserted. So the main area of our interest over in insert is the second dot second. So if what we are going to do is we are going to first s1 dot insert each element, that is nums of I. We are going to insert that. Then we are going to check dot second. As you can see over here, we are going to check dot second. That means if that value was successfully inserted, our dot second will return a true value, else it will return a false value. Let us just think that the value was successfully inserted. Then our entire this s1 dot insert insert nums of I dot second will return a true value, for which our and because of this not of true, our if will become if condition will become false, and this if condition won't work. But If the element already exists in the set and we try to insert the element again, then this s1.insert will return a false value, and hence our not of false will make this if true, and we will enter the if condition. Now let us check what are we doing inside the if condition. As you must have guessed already, we are just going to push back that element. Whichever element was repeated, that would be pushed back to our vector v1, and that v1 will finally be returned. Let us just check the implementation with the input set that we were provided with. So let me just clear this out in order to make the explanation part a bit easier for you. Getting back to where we were, as soon as we encounter 4, what will happen is s1.insert, just imagine that this is our set, so 4 would easily be inserted and we would have no problem, which would return in a true, and not a true would be a false, because of which this if won't work. And since it will not work, then we are good to go. Again, we come to 3. 3 also successfully will be inserted because 3 already doesn't exist in the set. So let us basically arrive to a case in which we basically enter this if condition, because that is the main area of interest, as I told you, because at that moment itself we are going to do a v1 dot pushback. So as you can see clearly, 2, 7, 8, these all elements will be easily inserted in our set without any issue. As soon as we approach this 2, what will happen is, yeah, as you must have guessed already, 2 is already repeated, and what will happen is when we try to do this s1.insert, our insert function will try first check whether a 2 is there, but just keep this in your mind. This is a rough implementation of the set. Set will automatically even sort the elements. That means our set would actually look something like this: 2, 3, 4, 7 and 8. This is something our set would look like. So as soon as we try inserting 2 again, first it will check whether 2 already exists. Yes, it will definitely find that 2 is already present in our array, in our set. So of course you must have guessed that our s1.insert would be returning a false value, and this not of false will make it a true value. And because of that, let me just clear this in case if you didn't see that not. So because of that not of false, this if will become a true value, and because of that our nums of I, that is this 2, will be pushed back to our vector. That means our v1 will now contain this 2. After that, as we approach this 3, again you must have guessed that 3 was already present. So because of that, again we will that insert function is going to check and it will find a 3 over here, because of which insert dot second will return a false value, which will make this if condition a true value, this if condition, entire if condition a true value, and it will enter this condition. And again v1 dot push back nums of I, that will result in 3 being pushed back to the vector. That means our v1 now will look something like this. And when we encounter the final element, that is 1, you can see that 1 was not present. It will check whether 1 is there, and you can see 1 is not present in the set, so 1 will successfully be added, which will result in dot second being of true value, which will not of which will make this a false value, and this if will not work. And because of that, we'll reach the end of the input vector, and the final vector that we received, that is v1, would look something like this, and that would be returned by this function. So this was our first approach. Quite simple, but do notice the key factors over here, that although our complexity has remained n, we have used an excess container over here, that is set, which does increase our space complexity. So although we managed to make our time complexity less, we did increase the space complexity. So let's check it out quickly, like what would this code result in. So as you can see, the code is accepted. Let me quickly submit the code in order to check what would be its runtime. As you can see, it's around 260 milliseconds, which is by far not that optimal, how much we see. So the second approach would go something like this. Uh, I've just uncommented the second approach right now, and we would be going back to our whiteboard in order to understand what our second approach would look like. So again, just like the way I did in the first approach, I would be explaining first what we would be going to do in the second approach. So in the second approach, the first thing that we would be doing is, why not sort the vector? Once we sort the vector, it's very clear that we would get a input vector looking something like this. That is, all the repeated elements would appear after each other. Then it would become very clear, and I hope many of you must have already guessed till now, that in this for loop, what we will be doing is just iterating throughout the entire vector, and the thing that we would be checking is whether the next element, and as you can see, we are just going up till the last but one element, because we always go only up till the last but one element only when we need to check whether whether in our if condition, which is enclosed inside that, if we are trying to access the next element, we always go up till the last but one element in order to not get a segmentation fault. What we are going to check now is whether our next element is double equals to the previous element. That means the basic thing that we are going to do over here is something like this, that just a moment. Yeah, we will be checking whether this 2 is equals to this 2, and when we find that these two values are equal, what we would be doing is we would be pushing back that exact element in our final vector, that is the v1, which is to be returned just like the previous approach. And that's how this problem goes. Short and easy. The only main thing, only the difference over here is the key factor. So I hope I didn't explain this problem. Just a quick look over the problem again, that we declared a vector v1 which is to be finally returned, in which we will be adding all those repeated elements as asked by our function. Then this is a basic thing that we are checking, that if nums.size is 0, that means if we are given with an empty input vector, we would directly return that. Means we would return a empty vector itself, because our v1 right now doesn't contain anything. So we'll just finish it over there. Else we would be doing the rest of the part. That is, first we would be sorting as the main idea behind this approach. Once it is sorted, our input vector will look something like this, and once it looks something like this, we'll be starting from the first element, and we will be going up till just the last but one element, and we will be checking whether our next element, that means when we are at this position, that is 1, we will be checking whether this 2 is equals to this 1. And as you can see here, it is not, so this if is not going to work. Then again our I moves to the next position, and when it checks that is this 2 equals to the next element, that is 2 again, so yes, we get a true value over here, which will make it which will basically make this enter this if condition, because of which that 2 will be pushed back. And the same case will happen for these two 3s, when there will be a comparison between these two 3s. 3 will be would be pushed back to this final vector, and hence at the last we'll be returning this vector. This was all with the second approach. So let us quickly see. As you can see, we have not used here any other any other container, and hence our space complexity is definitely going to be less. But just to keep into mind that here we have used sorting function, a sort function. And if we go by that, this sort would be done by something like quick sort or merge sort, then our complexity is going to be n of log n. And if and since we are iterating towards the throughout the entire elements, then this complexity would be n minus 1. And if we multiply these two, our overall complexity would be the order of n log n. So as you can see, this complexity is definitely greater than the previous complexity that we had got, which was just O of n. But the previous approach did have extra space, which increased the extra container, that is set, which increased the space. But here we don't have that. So here we have decreased the space complexity but increased the time complexity by certain extent. So let's see whether this solution would result in slightly better output or it would be the same. So as you can see, it is very little less than the previous one, that is 240 milliseconds, which is just greater than 14.04% of the C++ submissions. But if you closely look in the memory table, we have definitely used a memory which is slightly lesser than that. That is, here we used just by the figures given over here, that is 46.6 MB, but here we have just used 33.5 MB of space for solving this problem. Now let's come to the final approach that I have done, and let's look onto this, that how can we even make our space complexity less by not taking a separate container, and how can we make our time complexity also less by running it only through a linear complexity of order of O of n. So this is our task. So as I did in the previous both approaches, I would be first explaining what we would be doing in this approach. So in this approach, what we seek to do is we would be basically altering the elements of the given input vector. To understand that, let us go to the description of the problem that we had over here. As you can see that our the elements of the vector, input vector, is going to lie between 1 and n. That makes it very clear that if we try to access those values as the indexes, then we can check for those indexes that are repeated. In short, what we will be doing is that just think that we have encountered a value that is the first value over here, that is 4. So what we will be doing is in the nums of 4 minus 1, that is because it is going up till this elements can be up till n, and it is starting from 1, that is 1 to n, but our indexes are always from 0 to n minus 1. For that reason, in the nums of 4 minus 1, we are going to make that value we would be multiplying that value with minus 1, or we are going to make that value negative. We are going to make that value a negative value. The reason for that is whenever you're going to alter a vector, always try to see the boundary conditions, and you know that an element is always contained between 1 to n. So we will definitely not be having a value which is 0 or a value which is less than 0, that is a negative value. So once if we have altered those values, that means just think what is 4 minus 1 over here, that would return us a 3. That means nums of 3 is 0, 1, 2, 3, this value. So our updated vector would look something like minus of 7. Now whenever, if just think again a 4 is encountered, first we'll be checking whether our nums of again 4 minus 1, whether that value is less than 0. If that value is less than 0, then it's pretty much sure that that value had been encountered before, and that's the reason we had multiplied it into a minus with minus 1 to make it negative, and hence which value made it, that index have a negative value, that value would be returned. In this case, if just think of one more 4 was encountered, this 4 would have been returned. That means, in short, we know that an element can only appear more than 2 times, only exactly equals to 2 times as given in the question, that is appear only twice. That makes it very clear that if for the first occurrence of 4, if our -7 got changed to our 7 got changed to -7, once more when our 4, if just think this input vector had one more 4, whenever this 4 would be encountered, because of that the 7 would again be changed, -7 would again be changed to minus or -7, which would result in 7, and then we could check for the occurrence whether that element is a positive value, because all those elements who appeared only once will definitely have a negative value. But if that element has a positive value, that means it's very quite clear that that element had appeared twice, and this is the exact concept that you would be using over here. If you must have not understood this still now, you would be understanding the same thing once I start iterating to in the through my code. So as the previous approaches, we have declared a vector over here with the name v1, which will be finally be returned by this function. Then we are starting with 0, going up till the size of the vector, and then the thing that we are going to do is we are going to make the abs. The reason we have taken abs over here is we are pretty much sure that the altered values would anytime result in a minus of that number. So just in order to prevent that, we have used the absolute function in order to get a positive value in the end, because you know that absolute will always return the positive value of that number. That means if you give a -1, that will result 1. If you give a +1 also, it will result into a 1. So as you can see over here, let me iterate. We will be starting from 4. So nums of 4 minus 1, that is the third index, would be made equals to minus of okay, that nums have again has moved on to the next line, but this is minus of this is the most important thing. We would be altering the elements, so minus of nums of the same thing. That means we are going to check what is at the third index, 0 1 2 3 7, make it -7. So that was our command. I would be writing the altered elements itself. I would not be writing the entire thing. So this would look something like this, -7. Then we are going to check. At the same time, we are going to check because yeah, let's just check it at the same time. That is, if nums of the same index, that is absolute of the element, the current element, that is nums of I -1, that is 4 minus 1, which would result into nums of 3. So we are going to check whether this nums of 3 is greater than 0. So we saw that no, because of just altering it right now, it is -7 and that is less than 0. So you would not be doing anything, and this if condition is not going to work. We will be going to the next iteration for the next iteration. So the next iteration, 3 will be encountered, and it will check now nums of 3 minus 1. That is what is 3 minus 1? That is 2. So it will be doing nums of 2 equals to minus of nums of 2, which will be nums of 2 is 0 1 2. So this 2 will become -2. Now at the same time, it will check whether this is greater than equals to 0. So as you can see, it has been updated to -2, and because of that this will again, this if condition will not be working. We would go to the next element, and the next element encountered will be 2, and that would result in into, as most of you must have already figured out, that will result into nums of 2 minus 1, that is 1, make it minus of nums of 1, and then we are going to again check nums of 1 is greater than 0. That means nums of 1 in this case is 0 1, that is 3, make it minus of 3, and then we are going to check again. Again this is not going to work, so this will continue, this cycle is going to continue. So if you must have figured out, I'll leave that to you guys. I'll just be telling what it will look. As soon as 7 is encountered, this will result into 7, that is last but one element. That means this will become a -3. When 8 is encountered, the last element, that is 1, will become -1. And till now this if condition will not work because we have not encountered any case in which it is greater than 0. So as soon as we encounter the main area of interest, that is this number 2, which is finally repeated after this 2, so what will happen is, as soon as we encounter this 2, we will be again entering, and we would be making nums of let me just clear this off. We would be making nums of 2 minus 1, that is index 1. Make that index 1 equals to minus of nums of 1. That means make this 3 again minus of whatever element is over there. So as you can see, the updated value was -3. We are going to make it minus of -3, which is very clear, which would finally result back into this 3 itself that we have. Then when it will check for the same element in that index, that is nums of 2 minus 1, that is index 1, that is nums of 1, that is this 3 itself, that is definitely greater than 0. That means as soon as we encountered a repeated number, the value at that index became positive, because once negative, again whenever we made the negative of negative, we resulted in a positive. And because of that, that value became positive. As you can see, it became -3 first, then it became 3, which we finally wrote over here. So because of that, this 3 will finally be pushed back to this vector, and as you can see, we have again made use of absolute just in case that any negative value doesn't get pushed back in the vector, and nums of I is returned to this vector. And as you can see, the same thing will happen with the case of 3, when this -2 will again be converted to +2, because minus of -2 is +2, and because of that, again 3, that is this number which was causing this action, that would be pushed back. And as you must have guessed, nothing will happen for 1, because 1 minus 0, that is 4 till now, which has not been touched. 4 would directly change to -4 and nothing would happen. So the two elements in our final vector would be 2 and 3, which would be returned by this function, and that's all that is happening in the final approach. And as you can see and must have already figured out, our time complexity is order of n, and we have even not used any extra container in order to store the values. So let us quickly check what exactly will happen when we run this final code. For that, let me uncomment this code and quickly comment the previous code. And let me finally submit this code in order to check what the desired output will be. So as you can see, this is 108 milliseconds, which is faster than 95.58% of the C++ submissions. So that was all with the 3 approaches that I had to discuss in this problem. If you like this video, do hit the like button, and if you have not subscribed yet, make sure you subscribe this channel, Decode the Code, and also hit the bell icon to never miss an update. Also, do share it with your friends who are still looking for a better approach for solving this problem. And if you got any doubts or have a better approach, let me know in the comment section below, because I'm always open to learning. That was all with this video. I'll be meeting you shortly in the next video. Till then, bye bye, take care.